I'm Mike Werkheiser. I'm the Director of Model-Based Engineering at Belcan. We're a global engineering services firm.
And I'm Daniel Campbell. I'm the Vice President of Model-Based Definition at Capvidia.
So if you guys were in the previous session with Pratt and Whitney talking about their characterization journey, this is going to continue to beat the drum of characterization. So we'll keep to that theme. This is on characteristic accountability with NX MBD and QIF. So just a little bit about my company. So I work for Belcan Digital Engineering Solutions. So we focus on model-based digital transformation. Specifically, our teams focus on model-based systems engineering and model-based definition. And what we've done is looked at patterns of successful implementation from our prior experience and used that to inform our services offerings, which bridge between strategy and the tactical execution tasks. We've got a lead team where we focused on getting demonstrated implementers that have been through these journeys before and can help you navigate the perils of these transformations. We're active and vocal in industry engagement. We've got certified in Agile and GD&T. And then because all of our customers use every CAD software, every interoperable format, we're software agnostic. We will recommend software, we just don't. We have to use all of them. And then once your journey goes from strategy to execution to scaled execution, where you're creating MBD data sets or MBSE data sets at scale, we're backed by a company that's got significant bench strength and 65 years of engineering better outcomes over the industry verticals that are shown here.
And I can give a little bit of background about my company, Capvidia. So I work for Capvidia. Like I said, I'm the Vice President of the Model-Based Definition business. So our focus as a company is on the machine-readable side of model-based definition. So, understanding how, or help, providing the software technology to you so that you can generate MBD data that can be consumed by downstream consuming software to automate some of your workflows. We're a Siemens partner, and we work closely with Siemens in the area of model-based definition. And we work with really all industries. Most of our users are the larger OEMs that are looking into advanced technology like model-based definition, but we really cross all industries, as you can see here.
Very good. And both Belcan and Capvidia have booths in the Solution Center, so if we don't get to your questions in this session, come check us out. So I wanted to start with level setting on some terminology. Again, you heard some of these terms if you were in the prior session, but I think it's good to make sure we're all on the same understanding of what we're talking about here for terms. So we got a model-based definition data set on the right, and we're talking about characteristic accountability. So first, what is a product characteristic? And it's a trait, a quality, or an attribute on an element of a feature, and it can describe the size, the location, the form, or some property of that feature. So on our example part on the right here, our machine block with 4 holes, the product characteristics that we're going to focus on are there's a feature of size characteristic for all 4 holes, and then a true position on the pattern of 4 holes. And product characteristic tags, so these are human or machine readable tags that are applied to the product characteristics. So for this part, I know the numbers are hard to read, but the feature of size is number 3, is attached to that PMI element, and then the true position of the pattern of 4 holes is number 4. So because it is a pattern of instances, there's a parent ID that's attached to the PMI instance, and then there's instance tags that are applied to each 4 holes. So in characteristic accountability, we need to account for the characteristics. So we got to go further than just putting an ID on the parent and assuming somebody's going to figure out which hole is which hole. We've got to characterize each instance so that we can trace them. Then the next term is a bill of characteristics. So this is a list of all of the product requirements in this case in an Excel format or a tabulated format. And if we walk through the example of what's included typically in a bill of characteristics, you've got the characteristic IDs or the tags. You have the presentation state, or in NX, that's your model views where those IDs are present. The measurement object, so for that pattern of 4 holes, the measurement object is the cylinder. The PMI, which in this case is primarily GD&T. We're also referencing the data and reference frames for that GD&T. We've also got the concept of a UUID, or a universal unique identifier. Those can be applied at the characteristic tag level, and you can also call the bill of characteristics with its own unique ID. And then finally, what we're here to talk about, characteristic accountability. So that's ensuring all of your product characteristics, the requirements attached to those product characteristics, have been met with traceability through verification results, right? We want that full cycle of assigning the characteristics, mapping them through the manufacturing and inspection process, and then being able to map the results back onto the same characteristics. And just showing what that could look like here for those 4 holes. Again, we're identifying not just the parent IDs or the parent instances of the PMI, but every instance of the 4-hole pattern. All right, so next I'm going to talk about what does characteristic accountability look like today in a drawing-based environment. So if you look at the image on the top of the diagram, I'm going to build out a workflow. On the left-hand side are major process steps that are done by the OEM, and then on the right-hand side are the steps that would be done by a supplier or multiple suppliers. So we'll start, of course, with creating our 2D drawing. We're going to assign 2D specs. So examples could be weld specifications, heat treat specifications, where the 2D drawing will have a call out, weld per specification, and then you have a stack of specifications that have the actual weld requirements. We'll combine both of those data sets and then issue that product definition to the supplier. And then what the supplier is going to do as an initial step is characterize the 2D drawing. And that's going to take the form of, you might hear the term ballooning a 2D drawing. It's, most people use circles with unique numbers inside the circle. And they're assigning a unique ID to every, in this case, a 2D PMI instance. They're also going to have to characterize the 2D specs. So again, that can take the form of ballooning the 2D specs. So it's the supplier that is accounting for all the product characteristics in this workflow. Then they'll take the 2D drawing, balloon characterization, and the 2D specs and combine them to create the bill of characteristics. And often in a 2D environment, that's going to take the form of like an Excel file where a human's extracted the data from the drawing and the specs and manually typed that into an Excel file. So I think the key thing here is the complete bill of characteristics is being created at the tail end of the process, and it's being done by the supplier in this workflow. So if we say, how healthy is this process to the characteristics that we want to enable for a digital thread? Do we have a single source of truth for characterization? We don't, right? The characterization is unique to each supplier. If you take the same part and send it to 2 suppliers, they'll balloon it differently. The parent IDs will be different. Often the level of decomposition can vary across suppliers. So we have multiple sources of characterization truth. For speed, it's time consuming with little automation. There's a lot of transcribing data into Excel files. The quality, what's the quality of the artifact? Again, with all of those transcriptions, you're really error prone in these processes. And traceability. So if this part had a non-conformance on one of those 4 holes at multiple suppliers, right, it's a human going to figure out, well, what ID was assigned to supplier A, supplier B. They have to reconcile all that information to manually drive traceability. And then interoperability. We're really not supporting machine workflows here because we're not providing a format of the BOC that's in a machine or software-enabled workflow. So if I pause here, I guess for the people that make hardware in the room, does this match your current state, or how many people does this resonate with? Oh, thumbs up. Nailed it, all right. Yeah, so obviously like a lot of opportunity here, right? Oh, sorry, consistency. So what standard is being followed when all this characterization is done, right? There's really not an industry standard for characterization in a drawing-based world. We'll talk about an emerging one for model-based. So we saw what characterization looks like in a 2D drawing environment. We're gonna see what it could look like in model-based. And just to transition that conversation, this is how we talk about at Belcan, how we talk about the data elements that make up a model-based definition data set. You've got the geometry, I think everybody, that's the shape definition. Annotations, which can be GD&T and notes. If you drop to the lower left, attributes and parameters, that's the metadata. That's behind the scenes on the PMI. Presentation states are model views in NX. That's where you're telling the story of the part across multiple model views. And then we spike out characteristic annotations as a separate data element because there's so many workflows that can be driven off of it. All right, so same construct as the 2 slides ago. Let's see what this workflow looks like with model-based characteristics. So instead of creating a drawing, we're going to create an MBD data set. We still have to assign 2D specifications, like those weld and heat treat callouts. And then the red box is where we're going to see new process steps that are going to show up on the OEM side of the workflow here. So we'll start with characterizing the model-based definition. So it's the same parent and instance IDs that I showed you on the previous slide. We have the opportunity to characterize the 2D specs in engineering. There's software available to complete that step. Capvidia is one of the providers in that space. There's also the opportunity to merge the 2D characterization and the 3D data set to get a complete BOC as part of the engineering definition. We don't have details of that in this process, but Daniel and company, I'm sure, would be happy to show you what their software can provide for that workflow. And then lastly, we've got the opportunity to create a QIF file. That's our machine-readable format that's going to carry our characterization. So we take all of that data now, authored by engineering, we release our data package to the supplier, and the ask to the supplier is that they reuse the OEM characterization. So now comparing to what we did in the drawing-based world, what happened here? We've moved that characterization to the left, made it part of the engineering definition, and it's a complete BOC authored by engineering. So let's go back through those same, are we enabling a digital thread by making this change? So the first one was a single source of truth. Because we're authoring it in engineering and reusing it, we've got the opportunity to have a single source of truth here. Speed, because we've included QIF in the data set, we're enabling machine workflows. For quality, now we've got software integration that can replace manual transcription. And traceability is huge here, right? We've got unique IDs that persist in a digital thread assigned by engineering. And we're also supporting interoperability into consumption workflows, again, because we've included QIF in the workflow. And the next 2 slides, we're going to get into an emerging standard for characterization, and then Daniel's going to cover the existing standard, which is the QIF format for machine workflows. I'll ask the same question here. Is anybody experimenting in this space of seeing what characterization could look like for MBD? Got some head nods, so there's some hope. Keep it alive. So I'll cover the first standard that's in this ecosystem, and it's an emerging standard. It was referenced in the prior presentation. But the DMSE, the Digital Metrology Standards Consortium, the same group that controls the QIF standard, has authored this document. It's about 180 pages, and it's got the specific types, categories of product characteristics, and augmentations, like criticality is an example of an augmentation. But it's got nomenclature, definitions, symbols, and practice. In June of last year, they voted that it should move forward or be considered as an ANSI standard. I think the latest status is to get that approved in Q4 of this year, I think is what they're tracking. So my message here is if you're going to get into the space of putting characterization in your data sets, like rally around this standard. It's going to help with adoption. It's going to help software vendors focus on where they can drive automated solutions off of this standard. And the next slide, I'll hand it over to Daniel. He's going to pick up with the QIF standard and show how that QIF can be used in pretty powerful workflows on the consumption side.
Yeah, so the QIF standard, it's the Quality Information Framework is what it is. We've probably heard a lot about it. This is also governed by the Digital Metrology Standards Consortium. I'm a member of the board of directors of the Digital Metrology Standards Consortium, and I actually chair the QIF working group that's working on the next future version of the QIF standard, version 4.0. So the point of QIF is it's a data format for storing PMI information and then also a lot of quality-related metadata. Most notably, we're talking about the characteristics that are on a part and then measurement inspection results. So it's a feature-based sort of language, data language. Which means that the fundamental core of QIF is built around the idea of features and characteristics. So at the end of the day, that's what you have on your MBD model is you have characteristics which are governing or controlling certain features on your part. That's what it boils down to. It's built using XML, which is a big advantage from the QIF side because it means that not only can sort of professional software vendors like Capvidia come out with software that uses QIF, but actually it becomes very common for end users to be using QIF, to throw it at some of your data scientists. They could use Python to easily go in and extract data and do your own data manipulation, which is especially powerful when it comes to results data. One of the basic premises of QIF is that it's MBD based. That's sort of part of the whole point, is that there's all this quality related metadata, all the characteristics, all the measurement results that you have, statistics, but you want to tie that back to your product definition. You want to tie that back to your NX model stored in Teamcenter. I mean, that's your single source of truth. And that's sort of the core of where your digital threads should be spawning from. And so that's definitely very fundamental to the idea of QIF. And then finally, it's a standard. It's a neutral standard. It was first released as ANSI, and it is now it's now been moved into ISO. So it's an open ISO standard, which means that you can choose your favorite vendor in terms of what you want to be doing on your QIF implementation. Here is a diagram that shows some of the different application areas of QIF. I won't get into it in detail, but basically we're looking at the model-based definition, like I was saying earlier, the plans, which is basically your bill of characteristics, so it's a lot of the characterization that we're talking about. Resources, where you can describe the measurement equipment that you have, your CMMs, your calipers, things like that. Rules, where you can establish some best practices for how you want to process your MBD in terms of inspection, internal inspection policies or best practices that you might have at your organization. DEMIS, so DEMIS is mentioned here. It's not part of QIF, but it is closely associated with QIF because it's also a standard governed by the DMSC. And so there are links that were inserted in DEMIS to make sure that DEMIS could work closely in interoperability with QIF. Results, like I mentioned, very, very important one. I mean, this is how, you hear people talking about the idea of digital twin. I mean, this is a data format that was really designed for that purpose, tying together your MBD as designed model and then capturing information about your as-built product and keeping them, closely correlated. And then finally, statistics. It's just a method to be able to apply statistical process control there on some of the results that you're getting. And I will point out here, there is a nice blog that actually Belcan has put together, talking about QIF and kind of giving a good example of a QIF workflow. These slides, we can make them available to you later. Just come and talk to us. Come by our booth. We can make this available to you. So that's a little bit of background about the QIF standard. So now we've seen model-based characteristics standard. We've seen the QIF standard. So these are a couple standards to really empower you on model-based characteristics workflows. So let me get a little bit into some of the fundamental ideas about model-based characterization. So after this, I'm going to show you a very, very simple, specific workflow of a model-based characteristics workflow. But first, I want to talk about some of the ideas here, why this is important, and why this is a little bit of a change of thinking. So legacy state, the way that we currently think about, just thinking about enterprise data as regards the world of PLM, let's say. Really, we think in terms of a part at the lowest level. That's sort of the most atomic unit of data that we're thinking right now. That's the normal current state. But that's the point of the idea of model-based characteristics, is to start to think that we need to go below that level and go more granular. And not just look at the part. What we need to really look at is the characteristic. And understand this bill of characteristics, this list of all the characteristics that are associated with my part. Understand that each one of those is an important business object that needs to live inside of, sure, it's authored inside of a part, and it resides in Teamcenter, but you use that all throughout your enterprise. And it's this characteristic that is used to establish that digital thread. But there are uses for the characteristics in manufacturing, maybe through your MES system and quality, your QMS system, maybe your ERP system, gathering sort of actual results, supply chain software systems that you might use, program management, sustainment, etc. These are all different domains that are going to make use of your characteristics. So you need to start thinking about that business object. And that it really is one of what QIF satisfied is establishing a data standard that allows us to track characteristics throughout the enterprise. So let me get into an example of a workflow. One of the nice things about where we are now in terms of model-based definition is we can get away from just slides, just PowerPoint slides like we were just showing, and we can show some real software that's really doing some really cool things in the area of model-based definition. These are real workflows that we're working with active users. So what we're going to see is we'll start off by characterizing our model in NX. So that's our product definition. We have our PMI there. We're going to break down each of the characteristics that we see on this very simple little widget model. From there, we'll generate a QIF, and we'll break down the bill of characteristics. We'll generate that bill of characteristics and visualize it there inside of the Capvidia MBD video software. From there, we'll go to PCDMIS, which is one of the major CMM programming tools out there. And we'll author a CMM program and execute that. And then finally, the results that come out the back end, we will have traced that digital thread all the way through, and we can link those results all the way back with the model that started the whole process in the first place. So starting off here on the NX side. So we have our product definition. So what we see is just a few simple tolerances on this little widget part. But notably what we see is we can see the balloon numbers here. So this is often kind of a somewhat of a revolutionary way of thinking about authoring your product design is ballooning the actual design model. Anyone doing this right now on any of your data? A little bit, okay, yeah. So it happens, but it's not the norm for most people. But that's the way industry is moving. Like Mike was saying, this idea of pushing left the process of sort of understanding what your bill of characteristics is. And again, why is that important? The designer is putting the annotations on the part. All right, you're putting the annotations on the part because you need certain inspections done. So implicitly, whether that person knows it or not, they are creating a bill of characteristics. So what you should be doing instead is make it explicit. That PMI that you're putting onto the part, it should result in a specific bill of characteristics. That's the whole reason you're putting PMI in the first place. So that's our starting point, the characterizing that part inside of NX. So next, we'll take that NX model. We're going to generate a QIF model, which is a derivative model. It looks exactly like the QIF model in terms of all the annotations and the presentation states, and we'll characterize that. And we'll view that bill of characteristics. So here we are with, this is actually the QIF model we're looking at here. And what we'll be able to see is we bring up this bill of characteristics that's going to be brought up here on the bottom. And we can see how we have, balloon 1, 2, 3, and here we have the matching balloon numbers there on the QIF side. In other words, maintaining those same characteristics now through a derivative file that can be sent throughout your enterprise, throughout your supply chain. And here on the bottom, we view this panel. It's called the bill of characteristics. And so it's just, all your PMI broken down into a tabular format with all the characteristic IDs and a breakdown of all the semantics of it. This is a perpendicularity tolerance, this is the tolerance value, these are the datums that control it, so on and so forth. So now we've established our bill of characteristics. We're ready to go out and do a CMM inspection. So we'll take a look at PCDMIS. So again, this is a popular CMM software that supports QIF. It's not the only one out there, but it was it's a popular one, so I thought it would be a good one for this video. Probably a lot of you are using PCDMIS. So what we're going to do is we're going to pull that QIF file into PCDMIS. And what we're avoiding in all of this is we're avoiding the process of having some poor quality engineer looking at a PDF and typing this data into their software, which is ridiculous when you think about the fact that this is how we have to do. So we pull in all the MBD, all the PMI, but additionally what's being maintained through this QIF file is the notion of the characteristics. So you can see it here, this little black balloon that you see next to each annotation, that's the original characteristic ID that was established in NX. So here we are now through quality inspection, and we can see that digital thread being maintained at a characteristic level all the way through the CMM side. So it's going through, it's creating an optimized CMM path based on the PMI that's in there. And then we'll see the beginning of the simulation of the inspection. We'll see the probing system running around, carrying out the inspection, and so forth. So there we have now, we've created a CMM inspection based on our starting point of the NX PMI and the characteristics. So the final stage that we'll look at is exporting those results from PCDMIS, again in the QIF format, and we'll show how that link of the results is maintained, and we can view the results from that inspection back on the model. So here we are again in the MBD video software from Capvidia. We see that bill of characteristics, and we're going to insert the QIF results that just came out of PCDMIS. So down here we can see the inspection data pulled in. These are the results. 10 different serial numbers, 10 different parts were measured, and so we have the results from 10 different parts. We could do all kinds of statistical analysis of these results and so forth. But what we're going to look at is how now we have the characteristic authored in NX, the characteristic in QIF that we use to create sort of our measurement plan, and then finally the results coming back in from PCDMIS from 10 different parts, and it's all linked. Sort of maintaining that digital thread from front to back. And again, the cool thing here, this is real software. This is not just a PowerPoint concept. This is real software, and there are people out there doing this right now. So again, starting in NX, authoring that PMI, authoring our characteristics there, flowing through QIF, understanding our bill of characteristics, authoring programs in whatever your CMM software of choice is. In this case, we were looking at PCDMIS. And then finally, tracking those inspection results, maintaining the thread of that characteristic so that we could tie back all the way to that characteristic which is authored in NX. There's the last slide that I wanted to show is just, so for those of you that were in the previous talk, you saw this slide. George Rendell was talking a little bit about the Siemens vision for how characteristics fit throughout the entire Siemens ecosystem of software. And this is not just, these are not just sort of some crazy ideas that Mike and I are throwing out there in terms of characterization. This really is the way industry is going, and Siemens has a very, very clear vision, I think, of how characteristics can be managed throughout the entire life cycle, starting from NX. So I think, yeah, it's exciting to see industry really moving in this direction and getting some clarity in this area. And with that, we'll just take it to some conclusions. So I'll take the first one. First is just thinking about model characteristics as business objects. Really, that it takes a little bit of a change in thinking, but I really do want to encourage people to start thinking about model-based characteristics, or even your drawing characteristics, as important business objects that you need to track throughout your entire enterprise. I mean, that's kind of like a new way of thinking, but it's an important way of thinking.
Yeah, and I like that concept of a new business object here with characteristics, and that you can house your characteristics in a QIF file and support authored in engineering and support your supply chain, which has a diverse CAD ecosystem. It's really enabling a digital thread through the supply chain.
The next thing, I would say that this is, again, this is not pie in the sky thinking here. I mean, we're beyond the level of just high-level PowerPoint presentations and then a lot of hand waving. We have real software out there that could do these things. So, it's time to get your hands dirty and start running with your MBD implementation. Now's the time to do this.
Yeah, and last I highlighted in my slides that, of course, MBD and QIF can reduce manual data entry, but what we're really talking about here is supporting a digital thread. I see characteristics, it's the spinal cord of a digital thread, right? You have to have it, you have to establish it early, and it has to be traceable.
And with that, like we were saying, we do have some booths here. If you want to get these slides, or if you want to have some, in-depth discussion, come visit us there. But with that, I'd like to open it up for any questions. Yeah.
I'll try to talk about it for everybody. Is the intent for QIF? I mean, like we're a Pratt & Whitney supplier, so we're expecting a technical data package which will include QIF. Is the intent eventually for the QIF to replace the technical data package, that you only have to have the QIF and nothing else?
Yeah, so it's a good question. So is the intent of QIF to replace a full technical data package? So I would say no. There are going to be other files that are important in your technical data package. First of all, a 3D PDF or some form of maybe it'd be an HTML file or something, but something that can be viewed with something that's targeted for human consumption, either with a PDF viewer or a browser or something like that. That's a critical piece. There are going to be a lot of just specification documents that are going to be typically included in TDPs. There might be a lot of other files. In fact, in general, I think there is a temptation for people sometimes to try to think of like the one file that will rule them all. And I think that's a tough thing. I think it's better. QIF is very, very good at what it does, and it should focus on that. And then for other, whatever different use cases there might be a different file format. That's okay. I guess you might not want 100 files in your TDP because that just starts to get confusing. But to have some reasonable number of different files in the TDP, I think seems okay. Yeah.
You had a call out there where you had a whole and the next line down you had a countersink, but I only saw one number. And there's many instances where you've got a
Should have zoomed out.
diameter, a depth, a countersink, a diameter things there, but one characteristic on it. What's going on there?
Ran out of time.
Is
So,
the intent that every piece, if there's 4 data points, you got 4 characteristics?
well, here's how I would answer. Is that countersink or that chamfer a feature? It is.
Yeah. Oh, well, that's a good point, because
So-
some engineers put the chamfer in the model, others just call it out and draft it.
Yeah, it's a feature. So in this example, we'll fix it to have a characteristic on it.
But actually, that's a great question. I mean, and that goes to thinking about the difference between PMI, how you might just sort of apply PMI. Maybe it's even just like a note with some text in there. But you're thinking about characteristics. You know, like you're understanding that, you know, whatever this looks like on the screen, you know, at the end of the day, I have 2 different characteristics here. And that's precisely the type of thinking that's needed for these workflows. Yeah.
Because if we go to engineers and say, you must model every chamfer, and your pre-drill hole in the tap must go to, some people just make that pre-drill hole the same as the threaded portion, which is not usually a good idea.
Yeah.
So I'm just wondering, how much additional demand does this put on the engineer to do, you know, better modeling?
Well, yeah, I don't think it means that sort of there needs to be one row, that a complex hole like that needs to be broken down into sort of multiple rows with a characteristic per row. I mean, Dave, you might be able to speak more about the semantics of like complex holes on a single line.
Yeah.
I mean, that's, yeah.
You know, forcing it onto multiple lines is really something that you do for visual consumption, right? So the software will have the linkage between each subunit of that particular dimension and the specific characteristic, and you characterize that within the NX part. And then, you know, if you want to present it so that when you look at it clearly, you know, when you talk about human readability, talk about query response and stuff like that, that can all be enabled. Or if you want to use a format where you are literally row by row doing the characterization, that's something that you can format it to do.
So if you're saying, all right, I'm putting characteristic 36 on this threaded hole, I missed it if you did it, but are you kind of like associating that with the call out or with the face of the hole?
At least in the Siemens tool, you would, that PMI annotation or the balloon would get associated to the PMI tag, and it inherits the metadata from the associated PMI object. Yeah. But I would answer like a complex hole is a tricky one. But you do have to account for I would just say generally you have to account for all the features that make up the hole. You have to choose the right PMI type for all the features that make up the hole, because it's setting up metadata behind the scenes that's used by software.
So I guess one thing to know also about the PMI hole call, right, that's in NX, that's actually an amalgamation of multiple dimensions, each of them measuring the geometry that's in the part. So literally, even though we see it as a single PMI tag, in the database there's actually multiple dimensions there. And then the individually characterized it, that's what's needed, right? So it all depends on what you're attempting.
Yeah, so like the semantics are all there, even though it might look like one line. Like it's understood. You know, this is the countersink angle. This is the countersink diameter at the top, and yeah.
Like,
For the extensive customer base that both of you interact with, what do you see as potential shortcomings for the existing competency or skill set? You know, people have some knowledge of CAD, some knowledge of GD&T, no knowledge of characteristics. Is the solution to this by a geocode book again, or how do you guys think that adoption and education will best work? I think you're better suited to answer that.
yeah. Yeah, as you saw in the image, right, the biggest shift is moving that out of supply chain and putting it in engineering. I think it was the right fit for it to be in engineering anyway. As you said, engineers should be thinking about when they apply PMI, that is a characteristic. It's the additional task of putting a unique identifier so that it is traceable. So of course, all of the training and tools that have to go along with that, right? It's not an insignificant lift, but if you look at what it is in current state, what are you telling the suppliers to do? Right? It's usually a high-level document that says, please account for everything on the drawing. You're allowed to do whatever you want in that process. Yeah.
Giving up accountability to yourself.
That's right.
Yeah.
Well said.
So, working with a lot of fresh outs, they don't know or have never touched the machine, made a chip or spar,
inspected a part, who's responsible for assigning those characteristics to the master model before it's released in your PDM system or PLM system?
I think where you're going is you would say like a quality person does that today?
Well,
And you're asking for a change that an engineer does that today?
that's what it sounds like.
Yeah.
It sounds like you're putting this all in the RE, but those REs don't know anything about making a chip or a part.
Yeah, I don't think you have to know how the part is going to be manufactured to account for the features. Is how I would answer that. So if it's machined or additively made, you still have features on the part that need to be accounted for. That's what I think the baseline is you're asking the engineers to do, is account for your features.
Yeah, I mean, because there's a certain level of refinement that you can get into in the bill of characteristics. So for example, if you're creating your bill of characteristics, you could start to say, well, I'm going to measure these with the CMM, I'm going to measure these with the calipers, whatever. So something like that, definitely I could see that might not be the best sort of task to assign to design engineering. But the basic idea of simply applying, let's call them the balloon numbers to some of the annotations, that I think does make a lot of sense, because really, just going back to that idea, I mean, you're not just throwing annotations on the part for fun, you're putting them there for a purpose. And implicitly what you're doing is you're building the bill of characteristics. And so let's just make it an explicit task for that person, and they should understand it as such, But it is a big shift in thinking, I mean, that's for sure.
If you go back to the multicolored chart here on QIF, I think you're asking the engineer to define the QIF MBD, account for the features. The quality engineer could pick up the QIF file and enrich it later and say these types of features should be inspected with this type of inspection equipment based on my knowledge, right? So you can embed that type of information into the QIF. There's a framework to capture that type of information in the QIF. So it can almost be like a shared file that gets enriched throughout the process.
Well, wouldn't that create two separate files, your master file and then your master QIF?
That can happen, and actually QIF was designed to work in that way. So the way you can manage QIF within Teamcenter, for example, you release your part, you issue a QIF, which is a derivative sort of reflection of that part, and that's also locked in Teamcenter. And then, maybe you're generating quality planning information, maybe you're generating a bunch of quality results data. That can be stored in separate files in separate locations, but you can maintain that map back to the QIF in Teamcenter, which is, a mirror of your NX part. So that it was designed in that way. Yeah. Blake.
So I actually want to respond to him and then ask you guys a question.
Yeah.
So I've been a design engineer, quality engineer, reliability engineer, manufacturing engineer. Now I don't know what I am. But I historically find that design engineering doesn't like to dictate how something should happen until they get data back, and design engineering usually gets ticked off if everything is pass-fail, because everybody QEs use the age for the entire thing. And then they care about number 6. They care about the results data, because they wanted data, not pass-fail. So in this brave new world, if design engineering wants something, design engineering is beholden to saying that they now want the thing. And they don't have to say CMM, but maybe they have to say variable data versus attribute. Or something like that might have to happen. Or so we disappointed, because digital thread is a digital thread. But I'm wondering if you guys, do you think that the best way that we implement this in the future is the fact that a multitude of people in life cycle could edit characteristics or just augment them, or do we have to put rules down in place? I know who's sitting in front of me. How do you guys think we should, who should get to author such thing, and should it be anyone potentially, or should design engineering have to hold the cards?
Well, I mean, I'd be curious what Mike thinks about this, but I actually think it depends on industry. Like people, different companies make different types of parts that have very different life cycles. And so I think there's going to be some variance across different industries there. But in general, the idea of what Mike was saying is true, that, okay, you author just the, sort of, you put IDs on your characteristics, you define what your characteristics are and put IDs on them, as far to the left is reasonable for your particular industry, and then you augment it along the way. All the way through, you have results and you have, measurement data that's another augmentation to it. But I don't know, what are your thoughts?
Yeah, I was going to it almost feels like a life cycle state applied to the QIF file. I mean, if you look at these steps, right, they're really life cycle steps anyway. MBD's engineering, I think planning and resources feels like a quality function. Then results are going to happen after you make the part, right? So yeah, I always envision it like a file that gets enriched throughout the process.
So in my case, I would say 80% of the features, or even 90% of the features on 80% of my parts all have the same tolerance. It's all general milling. And I would love it if I could kind of use all surfaces, unless otherwise indicated, all surfaces profile 0.3 relative to ABC, all holes size H12, blah, 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 blah. And only those particular critical features would I actually add a characteristic to and be more specific than that. Is there anything like that that might be feasible?
Yeah, definitely. I mean, I think that's in line with this whole idea of characterization and the way industry is going. I mean, we're doing these exact things that you're describing with some of our
users.
users.
So not have to actually touch, let's say I've got 40 characteristics, but only 3 of them I want to touch.
Mm-hmm.
The other 37, I just want to say, if I didn't touch it, this applies.
Yeah.
That's possible.
Yeah, you might have an internal specification or something like that, and like, so I mean, one of the things that we're doing with some users is you have an internal specification, which is a big, long PDF document, and you have someone that knows it inside and out, and they know how to apply it to a part. Well, you could digitize that. And you open your part, and you throw that digital implementation, or the digital implementation of that standard at the part, and it'll automatically sort of apply the details of that specification to the given part that's open. So it's doing, exactly what you're saying. Yeah.
That example also sounded like a part family, and Siemens has.
No, it's not that they're part families. It's just that they're all designed to be milled, and any clearance.
Okay, general tolerances for that part family.
It's about the same.
Yeah.
Okay.
Yeah.
Got it.
Benny.
To add to that, you're referring to a reduced dimension model, reduced dimension drawing. That's really what it is. And absolutely, and we've been applying, or at least developing QIF with Capvidia for a while now. And because of model-based definition, you don't have to specify those dimensions because it's not on a 2D drawing, right? The supplier is actually going to be using that model, whatever it is, to program the CMM and the CNC anyways. Right? So they're not using your specification until it comes to inspecting it, right? Yeah. Which is where QIF comes in. But keep in mind also, if you have 200 different characteristics, which 75% of them you don't care because it's a general profile application, that will cost you money and time for supply to inspect those 75% other ones that could be used as general profile reporting back to you in different ways.
How do I do it so that the 75% that...
Yeah, so you would apply a general tolerance profile in your notes, and tag it with the QIF with the specification that allows you to tag it.
And is that the criticality one? If you have the criticality?
Well, if you have criticality, you would call it out, like a CTF or anything like that, right? You don't want them to miss something, you call it out, right? There's the time and money to more is not better, right? But there's a way to manage it. So we have to trust the supplier that if you have a preferred supplier, their process is going to be within a certain segment because they audit themselves and they report back to your supply chain and see how well they're doing. So if your profile and your tolerances fall within that, chances are you don't have to call it out. You can go through a different means to verify that they are using that, right? Without measuring each individual characteristic, which costs you time. So those are the things you need to consider when you go to MBD, because the model really is the source of truth, right? For the majority of this, something to think about.
Other questions? Yeah, Dan.
Gentleman in striped shirt, there's already a way to do that with existing NX tools.
Okay, well, I think there are cocktails soon, so you won't like us if we keep you longer. So, thank you, everybody.
Thanks, everybody.